Alright folks, welcome back to Moonshine Radio. Today we're going to take a back to basics series. Today down on the Moonshine Radio farm we're going to learn about what the heck is a dBm. A dB of a milliwatt basically. Basically it's a real simple equation. 10 log 10 of a milliwatt, that's it. So how do we convert 1 watt to dBm? Well, first we got to convert the 1 watt to milliwatt, and 1 watt is 1,000 milliwatts. How about that? Then we plug it in our 10 log 10 equation, chug the numbers there, and there you go. 1 watt is 30 dBm. Now if all this sloggy boggy stuff is too confusing for you, well, just fire up the old computer there and go to Google, and put in dBm to watt calculator, and someone will have a calculator already for you, so you don't gotta do any thinking. Now, why do we use dBm? What's the purpose of converting watts into dBm? Well, it's real simple. As we cascade things, it's real easy just to work in dB, because we simply can just add and subtract. Let's take our first example. We got a 40 dB attenuator, and we're going to put in 0 dBm. And our question today is, what's going to be the power output? Well, we simply take 0 dBm minus 40 dB, and we get 40 dBm. So the output power after a 40 dB attenuator is going to be negative 40 dBm. How about that? Now here's an example that often confuses people. Is here we got 50 dBm power, and we're going to put a 40 dB attenuator in front of it. And our question today is, what's the power output going to be? Well, when you're working with 50 dBm, better known as 100 watts, you have to check the rating of the attenuator. And as we see here, this 40 dB attenuator is only rated for 1 watt. So this is not a good idea, because what's basically going to happen is your attenuator is going to catch fire, smoke, and melt. So don't do this unless you want to set things ablaze. This is the suggested thing. Now we got a 40 dB attenuator and it's rated for 150 watts. Now we're in business. So our question today is, what's going to be the power output? Well, we simply take 50 dBm minus 40 dB, and we get 10 dBm. Now 10 dBm is a low power, and we can put that right to a spectrum analyzer and see that we're getting 100 watts. Are you starting to see why we use dBs and dBms? Because it keeps the math down on the farm real simple. Now here's a good one for you. We got an amplifier here. It's got a gain of 40 dB, and we want to know what's the power output. So if we put into the amplifier minus 40 dBm, what's the power output going to be? Well, we take minus 40 dBm plus 40 dB, and we get 0 dBm. How about that? That's pretty darn simple. Here's another one. We got the same amplifier with a gain of 40 dB, and now we're going to put into the amplifier 0 dBm. What's the power output? That's easy. We just say 0 dBm plus 40 dB. Well, that's going to be 40 dBm. Uh-oh, not so fast there. You see that little P1 dB number? Yeah, that's 1 dB compression point. That basically says that's pretty much the max power output of the amplifier if you want to stay in the linear region of the amplifier. How about that? So if you put 0 dBm into it, you ain't going to get 40 dBm out. Your amplifier is going to be in compression big time, and you'll be most likely to get somewhere around 16 dBm output power. Now, is that amplifier working in a linear region? No, it's highly compressed. Now, if you're doing FM, that may not be a big deal, but if you're doing an AM signal, this would be a horrible idea. Are you starting to understand why we gotta look at dBs and dBms and look at the spec ratings of amplifiers and attenuators so that we can make accurate measurements? Thanks for watching Moonshine Radio Laboratories. I'm your Dr. Moonshine. Have a good day. Figure I'll show you folks some of the filters. So at the bottom there's the 45 megahertz crystal filter. Here's a nice little airband filter, quite nice. Here's a little 5 megahertz filter, low pass, got on eBay. Quite well for $20 or $10. It was quite good. Moonshine Radio recommends this. And of course there's your little RTL. And I'll leave you also with a good book for those of you that are going to be studying engineering and would like to become a good electrical engineer like Dr. Moonshine. Well, you're going to have to read a book by the big boys. You're going to have to learn your mathematics and your calculus. You need calculus to get a good job, Johnny. So anyway.